Now this is our last kind of optimization problem. We have lots and lots of practice to do, but this is our last kind, and I call this problems where tables help, not drawings. You're going to see in a second that drawing won't help. For example, here's the problem. You run a small furniture business. You sign a deal with the customer to deliver up to 400 chairs, the exact number to be determined by the customer later. The price will be $90 per chair up to 300 chairs, and above 300, the price will be reduced by 25 cents per chair on the whole order. For every additional chair over 300 ordered, what are the largest and smallest revenues? Remember, that's just how much money you're bringing in your company can make under this deal. I think you can see right away drawing a picture isn't going to help. What am I supposed to do? Draw customers? Draw chairs? Not going to help. But we do need a formula, and if I don't have a picture, what do? Well, what we do is we make a table, enough of a table, so that we can see a pattern, and then we're going to use the table. Okay, so this is what I'm going to do. I'm going to let X, right, be the number of chairs over 300 ordered. I'm just going to write a number of chairs over 300. And I can just start making a table. Well, how am I supposed to make a table if I don't have any formulas? It's not so bad. So here we go. What I want to do here is put the price per chair, and over here I'm going to put revenue. Remember, that's just how much money we're bringing in if we do that many chairs. Now, I'm not going to worry about the number of chairs below 300. We'll talk about that at the end. I'm really thinking that they're not offering a discount until 300, so we'll just see what happens. Meanwhile, if they sell exactly 300 chairs, X is 0. We do know that the price per chair then is $90, right? And what's the revenue going to be? The revenue is going to be the 300 chairs times the $90. All right, now if I sell one more chair, what happens to the price? Well, the price goes down by a quarter, so don't simplify here. If we simplify, we'll lose the pattern. By the way, that's a theme that runs all the way through Calc 2. Don't simplify until you see the pattern. Now, meanwhile, what am I going to do? I do sell 301 chairs, but I'm not going to write it that way. I'm going to write 300 plus 1, and then I'm going to write 90 minus 0.25, just like that. Maybe I see a pattern, maybe I don't. Let's do this one more. If I sell 302 chairs, what happens to the price? Well, it's going to be $90. I could say 50 cents, but I actually wound up simplifying that. Let's write 2 times 0.25, just like that. That's the price per chair. Now, how much revenue am I going to bring in? Well, it's going to be the number of chairs. Don't write 302, write 300 plus 2. And over here, this is going to be 90 minus 2 times 0.25, like that. We're now in a position, I think, to write down a formula. If I sell X chairs over 300, this is just going to be 90 minus X times 0.25. Not the way we usually write it, but we'll fix that in a minute. What's the revenue going to be? It's going to be the number of chairs. Remember, that's going to be 300 plus X times the price per chair, which is going to be 90, minus, what do I get here? I have X times 0.25, so let's write that as 0.25X. How's that? Just like that. And there, right here, is the formula that we're going to use to try to finish the problem. So let me go up right here like this. And we're maximizing revenue, so I'm going to use capital R for that. So capital R, revenue looks like that. It's going to be that there. This is going to be 300 plus X times 90 minus 0.25 times X, like that. I'll erase the table. By the way, if all you do is come up with this formula and without the table, you'll get very few points on the problem. You have to show the work. The business department, for example, wants to be able to do much more complicated things than this. And even if you can see this one right off, it's good to be in the habit of making a table to see a pattern. Now, I'm going to simplify this a little bit so it looks better. Let's see here. What could I possibly do? I'm going to pull a minus 0.25 out the front. That's not going to affect the x plus 300. That is, however, going to change this. If I take 90 and divide it by minus a quarter, what I get is minus 360. So this is going to be something like x minus 360, like that. Now I do want to take the derivative, but I'm going to wait just 1 second because I'm supposed to look for a closed interval. If I have a closed interval, I can finish with a table. If I don't have a closed interval, I have to finish with a sign chart. So what I'm going to do is ask what was x. X was the number of chairs over 300. And for the part we're considering, they don't get a discount until 300, so x had to be 0. The most number of chairs that they were willing to rent was 400, and that's the same thing as saying x is 100. So we do have a closed interval. I'm going to get my little smiley face so I can finish this. Now I'm going to take the derivative. How am I going to take the derivative? No, I'm not going to take the derivative yet. I'm going to multiply it out. And you might say that seems like a mess, but it's really not. And if you take a second and look, you'll see that. I need to FOIL, so I'm going to get x squared. But that's going to be minus 360x plus 300x. That's minus 60x. And you can see that that part of the derivative is okay. What I'm going to get is going to be 108 and 3 zeros. All right, and now we're going to take the derivative. The minus 0.25 is a coefficient. It goes along for the ride. Looks like that. And what I'm going to get is 2x minus 30 plus 0. I can leave that off. Now what I'm supposed to do, I'm supposed to look for critical points. This is always defined. Be in the habit of that. Once we start doing harder optimization problems, that is going to really come into play. The other way we find critical points is by setting equal to 0. We're going to get x equals 30. Like that. Now, once I have x equals 30 and a closed interval, we know that one of the maximums, well, the maximum value has to occur at one of these 3 places, and the minimum value has to occur at one of those 3 places. So it's the only places we actually put in the table. So I'm going to put x right here. Right? And remember, this is back to r of x. And what I put is 0 like this, and 100 like this, and 30 like this. And I am going to let my calculator do this. It's fun to do it by hand, but it takes a little time and some explaining. So here we go. And the calculator says when x is 0, we make 27,000. And we knew that. By the way, the only way we can make less than 27,000, I think. Nope. If it's 100, I make 26,000. I can certainly make a lot less than 26,000, by the way, if they only rent 10 chairs. But we won't worry about that. I'm just going to worry about this part of it. When I plug in 30, I get $27,225. Now, since we're on a closed interval, and we have all the critical points, the maximum value has to occur at one of these 3 places, and that's the maximum value. So this is the greatest revenue. I'm not going to worry about too much of the nuances here. This is pretty much what people want to do, so let's just leave it at that.